Hey, Austin. Hi. We are in our packet, page 30 and 31. This is solving multi-step inequalities, and we will start off with the toe the line investigation. So I already pre-wrote the two statements in maroon outlined in green. This is the less than sign pointing to the left. It's pointing to the left. And this is the greater than sign pointing to the right. All right, so if we can understand those two concepts, less than points to the left and greater than points to the right, we'll tackle this investigation on at this moment. So we need to fill in this middle column. And we're going to read the operation on the left, read the two numbers, and then either write less than or correctly write greater than. So let's check it out. The starting number is 2. The other number is 4. 2 is less than 4. Okay, next we're going to add 2 to both answers. So 2 plus, plus 2 and 4 plus 2 would now make this a 4 and this a 6. Okay, so we're going to read 4 is, again, less than 6. So we can keep our less than sign. Now it says we're going to subtract 3. 4 subtract 3 is 1. 6 subtract 3 is 3. Now let's read this again. 1 is less than 3. So we will write another less than. Then we're going to add a negative 2. We're going to add negative 2 to 1. And a negative 2 to 3. And negative 1 is still less than 1. Okay, now we're going to subtract a negative 4. Subtract a negative 4. Well, you guys know that a subtraction next to a negative is a negative negative. A negative negative changes to a positive. So that's really negative 1 plus 4 and a positive 1 plus 4. So now we have 5 and now we have 3. 3 is less than 5. So far, so good. Now we're going to multiply that by 2. So times 2 times 2. We get 10. We get 6. Again, 6 is less than 10. So far, so good. We've added, we've subtracted. We've added negatives, we've subtracted negatives. Now we've multiplied by 2. Let's go ahead and subtract 7. 6 subtract 7 is negative 1. 10 subtract 7 is 3. Again, negative 1 is less than 3. Now we're going to multiply by a negative 3. So times negative 3 times negative 3. Negative 1 times negative 3 is 3. 3 times negative 3 is negative 9. 3 is now greater than a negative 9. So when we multiplied by a negative 3, the sign changed. Okie dokie, let's go ahead and add 5 to that. That's 8. Let's add 5 to that. Negative 4. Guys, 8 is still greater than negative 4. Okay, we're going to divide both numbers by negative 4. 8 divided by negative 4 is negative 2. And negative 4 divided by negative 4 is positive 1. Negative 2 is less than 1. So dividing by a negative 4 changed the direction of our inequality sign. Okay, now it says subtract 2. Now subtract 2. Negative 4 is still smaller, less than negative 1. And finally, we are going to multiply by a negative 1. So times negative 1 times negative 1. That becomes a positive 4. That becomes a positive 1. Now 4 is back to being greater than 1. So I circled the 3 rules that made the direction of the sign change. Can you see what made the direction of the sign change? Adding and subtracting did not make the sign change. Multiplying by a 2 did not make the sign change. Multiplying by a negative made it change. Dividing by a negative made it change. Multiplying by another negative made it change. So what's the moral of the story? When I divide or multiply, when dividing or multiplying by a negative, remember the direction of the inequality sign changes. There we go. Spelled it right. You could also say when you multiply or divide by a negative, you flip the sign. That's the same meaning as above. Okay, so here is our rule. This is our rule that we'll go by based on our investigation. When we're solving inequalities, multiplying and dividing by a negative changes the direction, flips the sign. And we can see why by our investigation. Every time we multiplied by a negative or divided by a negative, the sign changed because the number changed. All right, now we are going to solve inequalities and graph the solutions. In inequalities, you have an infinite amount of solutions. And we'll show that on the number line. Let's review our steps. They are the same steps as equations. We're going to distribute first, combine like terms. On the same side, move the variable with the smaller coefficient to the other side by adding or subtracting add or subtract the constant, multiply or divide the coefficient. Now you have to decide, am I flipping it because I multiplied or divided by a negative? Yes, you are. So that is your little reminder. And then you have to graph your solution set. Graph the inequality, graph the solution. All right, number one. First is going to be combine like terms on the same side. So 8, negative 8, minus 1 makes negative 9. Negative 9x is less than or equal to 9. Now I'm going to divide by negative 9. Anytime I divide by a negative number, I remember to flip the sign. Here we go. UT beat Louisiana last weekend, so in honor of UT, we will be graphing in orange. Now my inequality does flip. It says X, meaning all of the answers that I am going to graph, X, all of the answers, are greater than or equal to negative 1. So if that's 0, and that's negative 1, that's negative 2, and that's positive 1, and that's positive 2, well, greater than or equal means equal, bubble me in, and greater than means shade to the right, because right means greater. So these are all the solutions that makes the original question true. Let's look at our second example. First thing I'm going to do is subtract 7 to both sides. This is a two-step problem. Now remember, subtracting does not make the inequality flip. Subtracting and adding do not change the direction. 6 minus 7 is negative 1. Getting a negative answer doesn't change. The only thing that changes is multiplying or dividing. So you guys will see that we are dividing by negative 3. The opposite of dividing is multiplying. So we will multiply by a negative 3, which means we're going to flip the sign. Go ahead and flip it. The 3's cross out. Negative 1 times negative 3 is positive 3. So the y represents all the numbers that are true. Y is greater than 3. So on your number line, go ahead. And greater than means open circle and shade greater. And those are all the solutions to the problem. We only shade the answers or the solutions. Okay? So far, so good. Please press pause and rewind if you need to hear everything again. Okay? Okay, our next example does use the distributive property. 2 times 4 is 8. So I'm going to distribute. 2 times 4x now is 8x. All right, so after we distribute, we're going to combine like terms on the same side. 8x's minus 6x's makes 2x's. Now I'm going to subtract 8 to both sides. That would make 2x is less than or equal to 6. Now I'm going to divide by 2. Dividing by a positive doesn't do anything. Don't change it. So x is less than or equal to 3. All of the answers that are the solutions are less or equal to 3. So put your 3 on your number line. I know that's 4 and I know that's 2, and I need to go less than 3, which is this way. Those are the solutions. Our next example is pretty intense. First off, I'm going to squeeze a 1 right here, and I'm going to say that it's really meaning a negative 1 times 5x, a negative 1 times 6. It does change the sign. First thing I did was distribute. And then I'm going to rewrite everything else as it says. All right, it looks like we have some like terms on the right side. So my like terms would be negative 6, take away 2 is negative 8. Doesn't matter if you want to put the negative 5x before it or after it. And in my case, I'm just going to place it after it. On the left side, these are not like terms. I will just recopy what I already had. Next, I'm going to get the variables together. Remember how my little PowerPoint said, do you have a variable on both sides? And we do. Which one's smaller? The negative 5. Do the opposite. Positive 5. That's what my PowerPoint said. That makes 0. And I'm going to just, running out of room, I'm just going to do this next step. I'm going to add the constant to both sides. So if I'm going to bring 5x to the left side, I need to bring 13 to the right side. I need my x and my constant to be opposite each other. 9, 10, 11, 12, 13, 14. That's 14 x's. And negative 8 plus 13. 9, 10, 11, 12, 13 is a 5. Now I have 14x is greater than or equal to 5. Last step, I'm going to divide by 14. And x is greater than or equal to 5 over 14. 5 over 14 is a very small number called 0.36. 0.36. So 0.3 is in between 0 and 1. 0.3 is somewhere around here. And it says x is greater or equal to 0.36 or 37. So I need a greater than, which is to the right. Final answer. And that's a 5 divided by 14. What types of solutions are possible when the variables are eliminated when solving? Okay, so we worked on this a little bit before today because our test did have questions where the variables crossed out. So remember when the variables crossed out, we either got infinitely many solutions or we got no solution. That's what happens when the variable crosses out. So let's check out what A says. First, I'm going to combine like terms. These are on the same side. 5x's minus 5x's is 0. I am left with 3 is greater than or equal to negative 7. Well, this is true. 3 is greater than a negative 7. Now remember, this says greater or equal. So it could be greater or it could be equal. So because 3 is greater than negative 7, it's true. Or means it could be greater and it's true, or it could be equal and it's still true. Just has to be true for one of them. Because it's true for the greater part, we get to graph infinitely many solutions. So we already said yes, and infinitely many solutions means infinite. So it's going to look like this. All of the number line is colored in because these are all the solutions. So let's first wrap your mind around that. The x's canceled out. I had a number on the left, a number on the right, and in between the 3 and the negative 7 was a sign. I read the sign and I ask myself, is that true or is that false? Does it make sense or is it dumb? All right, let's check out B. We have negative 2 is greater. Again, I'm going to combine like terms on the same side. Negative 7 plus 7 is 0. Is a negative 2 greater than 4? No, that is false. Negative 2 is not greater than 4. That means there's no solution to this problem. So the word false and the words no solution kind of go together. And the word true with infinitely many solutions goes together. So when you have no solutions, you have nothing graphed. So that just means this should be empty. That's the answer. If there's no solution and anything we color in means it's the solution, we can't color anything in, or that would mean there's a solution, and there's not. All right, folks, thanks for tuning in. Turn to the next page in your packet, which it is page 32, and that is your homework tonight. Thank you.